Awesome. So up next is Team H&H. Shannon and I have had the privilege to work with the amazing team. So they work closely with Mr. Grant Belton and Dr. Paul Cherukuri from the Institute of Biosciences and Bioengineering. Basically, they are working on a haptic feedback for the helmet used mainly by soldiers.
Team H&H was very adaptable this summer. They handled a couple different project pivots with admirable patience and perseverance, and I really think their flexibility and openness to new ideas resulted in some amazing progress, which you will see right now.
Okay. The following content shows military soldiers engaged in combat and can be triggering to some audiences. As such, we would like to encourage everyone to take care of themselves and prioritize their well-being. This video shows a military soldier engaged in combat. As you can see, this is a very stress-inducing environment and can take a toll on visual and auditory senses. As such, additional technology is needed to help soldiers perceive their surroundings. One such technology is haptics. So what are haptics? Haptics are the science and technology used to convey information through touch. Hi, my name is Faraz, and I'm gathered here today by my colleagues, Jesus, Hamza, and June, and together we are Team H&H. Current military helmets have 3 primary limitations. The first limitation is sensory overload. Having to sense and interpret everything simultaneously can be very overwhelming for soldiers in a combat environment. The next limitation is spatial awareness. Current helmets do not account for visual obstructions or low visibility environments such as smoke or fog. And lastly, communication. Soldiers are reliant on verbal communication as a means to convey information.
With these limitations, we find that the current available military helmet options do not provide spatial or environmental inputs to soldiers, which resulting in inefficiencies during deployment. A previous senior design team has worked on solving this problem through creating a smart helmet. Their solution involved 4 thermal cameras giving us a 360-degree view for threat detection. That information is conveyed to the users through a radar display. They have also incorporated a Google Glass to display important vitals such as heart rate. And lastly, there's also an accelerometer connected to the Google Glass to detect concussions. Our mission this summer is to develop a haptic feedback system which will eventually be incorporated into a smart helmet that sends digestible, intuitive cues to soldiers that work to maximize their situational awareness. We have devised a solution with the following components. First, a headband that houses 8 LRAs, or linear resonant actuators, that outputs the vibration to the soldiers. They're attached to the headband with our 3D printed RLA casings. Second, there's an electronic storage unit, which contains a battery that powers our system, an amplifier which amplifies sound waves, and a sound card that converts signals.
Our haptic feedback system achieves 3 main accomplishments. First, threat detection. If there is any threats that coming at a soldier and they cannot see it, maybe because it's out of their vision field, the haptic system would notify them at a particular angle this threat is coming at. The second function is a queuing function, which eases the communication between soldier and soldier, commander to soldier, all soldier to commander. If the environment is very noisy and they cannot communicate effectively verbally. The third feature is a wake-up feature. If the soldier is dozing off on a mission, we want to wake them up so that we prevent any issue. For our user testing for threat detection, we focused on having test subjects do physical activities at varying levels of difficulty. You can see jumping jacks and push-ups, and we would simulate a threat coming at them at a very particular angle. And they would tell us which tactor at that angle buzzed, and if the angle of the tactor matches the angle of the threat, that would be a success. And we have found that 100% of the users are able to identify at least 75% of the threats while performing those physical activities. Our second test was about queuing. We made these 4 queues, and the logic behind them was them to be as intuitive as possible. For example, attack, the 4 LRAs at the front would buzz, simulating an enemy in front of you. Retreat would be like just at the back. Regroup will be going anti-clockwise, and then find cover would be as if The left side would buzz, then the right side would buzz, simulating a soldier taking cover between two walls, for example. After conducting the training, we tested on the users, and then they got 100% of the answers correct. We got them back 3 days after that, and they still got 100% of the answers correct. Our last feature is the wake up feature, and we would buzz all the LRIs at the same time. We tested with 3 different waves, sine wave, square wave, and saw waves, and we asked test subjects to rank them from 1 to 5, 5 being the most annoying and 1 being the least annoying. And then, we found out that square waveforms are the most annoying at 150 hertz frequency, if you see on the graph.
For further iterations of our project, we would like to see our haptic feedback system fully integrated into the current smart helmet, as well as IRB approval for more thorough and expansive user testing with a population sample which more accurately depicts and represents the current military population. And lastly, we'd also like to connect all of the input sensors in the current smart helmet to our haptic feedback system. Before we wrap up, we would like to thank our clients, Mr. Grant Belton, Dr. Paul Chiricuri, as well as the OEDK and RISE 360 for all of their help, as well as everybody else on this slide. In summary, we developed a functional haptic feedback system to accomplish 3 main features, which are directional threat detection, cueing, and sleep prevention. And all of this was to maximize the situational awareness of soldiers and ensure their safety. With that, we'd like to thank you for your time.
You mentioned an acronym, IRB testing, and I'm unfamiliar with that. What is that? It was on the slide before this one, I think.
So IRB is a board for research, which is actually the Institutional Review Board. And so it allows us to, if we get their approval, conduct like an actual testing environment that's like more thorough and has a lot more documentation, and that will allow us to test on a larger sample size, since we only had the opportunity to test with those fellow interns around the OEDK.
Okay, thank you. And second question is, do you anticipate the final design being waterproof, and how long do you think the battery life would be out in the field for a soldier?
Yeah, so that was 2 main questions that we asked to some of our potential users. And they don't have to be waterproof, they have to be sweat-proof, and the final design would be sweat-proof. And for the batteries, because the batteries will also, there are 4 thermal cameras that will use the batteries with the system. So the batteries would last a day, 17 hours to be exact when we asked our users. And they would also be rechargeable. Potentially, a soldier will carry 2 batteries and with them so that they can change them, and both batteries can be rechargeable.
How does the helmet know when the soldier's falling asleep and then set off that annoying alarm?
Yeah, so this is actually something that we were kind of debating upon. And so one thing that we kind of looked at was vital measurements. So if you wear like a smartwatch or like an Apple Watch, oftentimes it could track your sleeping habits and stuff like that. And the way it knows if you're sleeping is through your vitals. So oftentimes it could track your heart rate. Sometimes if it goes to a certain heart rate and there's not a big change in heart rate, then it could detect that you're sleeping. And so just tracking the vitals is one thing that we considered. We also considered using an accelerometer to track like dozing off motions. And so those things are still under consideration, but those are 2 main things that we considered.
So I just have a quick question. So I see on the picture there you guys have a storage area, I assume, for these sound cards and amplifiers. Where do you envision the storage will be when you have to incorporate everything into a helmet?
Yeah, great question. So when we're doing user interviews, we heard that a lot of soldiers usually carry backpacks on missions anyways. So we do envision the current fanny pack to be incorporated into the backpack so they can store their batteries, other equipment, and everything in there. So it'll be an integrated unit.
So I was just wondering, in the end, because I see that like there's like a lot of cords that are like going on like the back of the head. Like, did y'all maybe think or brainstorm about like maybe like a way in which like you wouldn't have those cords? Because I think like they might be like bothersome to some like soldiers or might get in the way. I don't know if you like thought of anything like that.
Yeah, so this haptic system is actually kind of, we designed it to be independent from the helmet. When we incorporate that into the helmet, ideally, these wires will be housed in the actual helmet. So they will not be kind of like on your face, drooping down.
So on one of the slides, you had a diagram of different commands that could be given and different signals that can be received. Do you have any device planned to transmit those signals? Like how would a commander give those signals? Are these helmets, can they be networked? So can a commander see what his soldiers are seeing in the field? Does this go back to a command structure? Is this localized? So anything on any of those questions?
Yeah, so last senior design team worked a lot on the sensors. So like I said before, there were thermal cameras and communication systems. So in the future, for the future teams, we do envision that our haptic system will be incorporated with the sensors to make to streamline communication and to make commander-soldier communication more effective.
The weight of the system?
The weight? Yeah, that's a great question. When we did user interviews, I think the current helmet is about 2 pounds, if not mistaken. So we want to keep it within that range, but for our haptic system, it's pretty light, so I don't envision it to be a problem or to add extra weight when it's actually incorporated into the helmet.
Yeah, and then in the final prototype, the amplifier, the sound card, and the batteries are not part of our system because they will also give power to the cameras. But then the sound card and the amplifier will be smaller. They will be PCBs, and for detectors, we were more concerned about the size. So they're within 1 centimeter. They're 1 centimeter thick, so that they can be incorporated inside the helmet.